A clear coastline can disappear in minutes when warm, moist air slides across a much colder surface. That is the simple engine behind advection fog. Instead of air rising and cooling, the air moves sideways over cold ocean water, a chilled shelf, or cool land, and loses heat from the bottom up. As the lowest layer of air cools, its temperature moves closer to the dew point. The dew point is the temperature where air becomes saturated and can no longer keep all its water vapor invisible. When that point is reached, water vapor condenses into tiny droplets, and those droplets hang near the surface as fog. The process works best when three ingredients line up: moist air, a colder surface, and enough wind to keep feeding that air across the temperature contrast. If the air is too dry, fog struggles to form. If the surface is not much colder, the air may cool but not enough to reach saturation. Over the ocean, fog can form quickly because sea salt gives water vapor something to condense onto. These tiny particles are called condensation nuclei. Dust and smoke can play the same role over land or near industry. Once droplets appear, they scatter light, and visibility can drop sharply along beaches, harbors, runways, and shipping lanes. The boundary layer is important here. That is the thin slice of air closest to the ground, or sea. In advection fog, this layer is cooled from below, so the fog often stays flat and low rather than growing upward like a storm cloud. A stable marine layer can trap the fog near the surface for hours. That is why it may not clear soon after sunrise. If cold water remains underneath and moist air keeps arriving, sunlight alone may not be enough to mix the fog away. Around Australia, cold water is often the clue. Southern ocean waters, Bass Strait, exposed southern coasts, and some coastal temperature contrasts can all help set the stage. The Leewin Current and East Australian Current also shape local sea surface temperatures, which can either reduce or sharpen the contrast needed for fog. Near the Great Barrier Reef, local differences between warm air, cooler patches of water, and land can still matter when humidity is high. Advection fog is different from radiation fog, even though both can look the same to drivers. Radiation fog usually forms overnight on land under clear skies and light winds when the ground loses heat and chills the air above it. Advection fog depends on moving air crossing a colder surface, so it can form during the day and persist in coastal wind. The warning signs are practical. Watch for air temperature and dew point sitting close together, moist wind moving from one surface to another, and a flat fog bank creeping along the water. If visibility starts dropping near the shoreline, slow down, use low-beam headlights, and allow extra space. On the water, check Bureau of Meteorology forecasts and marine warnings because landmarks can vanish quickly. For pilots, mariners, and commuters, the key message is simple. When moist air meets a colder surface, fog can build fast and linger longer than expected.